Since beginning scientific operations in 2022, the James Webb Space Telescope has transformed modern astronomy. Built to observe the universe in infrared light, Webb allows scientists to see through clouds of cosmic dust, study the earliest galaxies, and investigate planets orbiting distant stars with a level of detail never achieved before. Unlike previous space telescopes, Webb was designed to answer some of humanity's biggest questions. How did the first galaxies form? How do stars and planets come into existence? Could worlds beyond our solar system support the conditions necessary for life? With every new observation, the telescope provides fresh evidence that the universe is even more complex than scientists imagined. One of Webb's earliest achievements was producing the deepest infrared image of the universe ever captured. This remarkable observation revealed thousands of galaxies packed into an area of sky no larger than a grain of sand held at arm's length. Some of these galaxies existed only a few 100 million years after the Big Bang, allowing astronomers to study an era that had previously remained almost completely hidden. Instead of finding only small, primitive galaxies, Webb discovered several surprisingly bright and well-developed systems that appeared much earlier than expected. These observations have encouraged scientists to refine current models describing how galaxies grew during the universe's earliest history. Rather than overturning modern cosmology, Webb is helping researchers build a more complete picture of galaxy formation. The telescope has also transformed exoplanet research. Thousands of planets have already been discovered around distant stars, but Webb can do much more than simply detect them. Using an advanced technique called transmission spectroscopy, the telescope studies starlight that passes through an exoplanet's atmosphere during transit. As the light filters through atmospheric gases, different molecules leave unique chemical fingerprints. This allows astronomers to identify compounds such as water vapor, carbon dioxide, methane, and other molecules that reveal the composition of distant worlds. These observations provide valuable clues about planetary climates, atmospheric chemistry, and the incredible diversity of planets throughout our galaxy. Webb has even directly imaged several giant exoplanets, demonstrating its remarkable ability to observe objects previously hidden from view. Closer to home, the telescope has also revealed extraordinary detail within familiar objects inside our own galaxy. The Southern Ring Nebula, created by a dying sun-like star, appeared dramatically different in Webb's infrared images. Layers of gas, dust, and previously hidden structures became visible, helping astronomers better understand how stars end their lives and recycle material back into space. The famous Carina Nebula offered another spectacular example. Webb's infrared vision penetrated thick clouds of dust, exposing hundreds of newborn stars still forming deep inside the stellar nursery. These observations allow scientists to study star formation almost from the beginning, revealing processes that ordinary visible light telescopes cannot easily observe. Every new image demonstrates that infrared astronomy opens an entirely different window onto the universe. Yet perhaps Webb's most exciting discoveries are only beginning, as astronomers continue analyzing enormous amounts of new data collected every day. As Webb's mission continues, its discoveries extend far beyond beautiful photographs. Every observation provides scientists with valuable data about the physical processes shaping the universe. One fascinating target has been Stephan's Quintet, a famous group of interacting galaxies located hundreds of millions of light-years away. Here, gravitational interactions trigger enormous waves of star formation while also feeding supermassive black holes hidden inside galactic centers. Webb's infrared instruments penetrate clouds of dust surrounding these energetic regions, allowing astronomers to study processes that remained invisible for decades. Another remarkable object is the Phantom Galaxy, also known as Messier 74. Although already impressive in visible light, Webb revealed an intricate network of dust lanes, glowing gas clouds, and young star clusters spread throughout its elegant spiral arms. These observations help scientists understand where stars form and how spiral galaxies continue evolving over billions of years. Webb has also expanded our knowledge of unusual worlds beyond ordinary planets. One example is VHS 1256b, a young planetary mass object whose atmosphere contains thick clouds of hot silicate particles. The telescope detected signatures of water vapor, methane, carbon monoxide, and carbon dioxide, providing one of the most detailed atmospheric studies ever performed on such an object. These measurements improve our understanding of weather systems under conditions completely unlike anything found within our solar system. Closer to Earth, Webb has begun exploring Titan, Saturn's largest moon. Titan possesses rivers, lakes, and rainfall, not of water, but of liquid methane and ethane. Webb observed methane clouds moving through Titan's atmosphere, offering scientists valuable insight into its complex weather cycles and seasonal changes. These observations complement previous discoveries made by the Cassini mission while extending them into new infrared wavelengths. The telescope has also examined remarkable galaxies undergoing intense bursts of star formation. One famous example is ARP 220, the result of two galaxies merging together. Infrared observations revealed enormous regions hidden behind thick dust where stars are forming at rates far exceeding those inside our own Milky Way. Such observations help astronomers understand how galaxy collisions influence star formation and the growth of supermassive black holes. Perhaps the greatest strength of the James Webb Space Telescope is not any single discovery. It is the ability to connect many different fields of astronomy into one larger story. From the first galaxies that emerged after the Big Bang, to newborn stars inside nearby nebulae, to planets orbiting distant suns, Webb is showing that the universe is an evolving system filled with complexity at every scale. Every observation challenges scientists to ask new questions. How did the earliest galaxies grow so rapidly? How common are Earth-like atmospheres? What role does dark matter play in shaping cosmic evolution? Future observations may provide answers that reshape astronomy once again. The James Webb Space Telescope was built to explore the unknown. With years of scientific observation still ahead, its greatest discoveries may not have happened yet. As Webb continues peering deeper into space and farther back in time, humanity moves one step closer to understanding how the universe began, how it evolved, and where our own place fits within its extraordinary story.